In this paper, we introduce interaction techniques for putting clothes on 3D characters and manipulating them once they're there. We first describe how to put clothes on a body from scratch. The system has two windows. The user manipulates a 3D character in the 3D viewing window on the left and edits a 2D cloth pattern in the pattern design window on the right. To put the clothes on the body, the user paints freeform marks on the clothes and on the body with left mouse click and drag strokes. The marks on each surface are numbered in the order they're drawn. When the user presses the Wrap button, the system places the clothes on the body so that corresponding marks match. Wrapping happens instantly. The user can create a sewing constraint by connecting two edges in the 2D cloth pattern editor. In laser paint mode, freeform marks are painted on both sides at once for the user's convenience. Here's another example. Our technique is useful for putting on clothes in non-standard ways. Now, let us put a shirt on the character. Again, laser paint mode is used to paint marks on both the front and back sides. Internally, the system grows the clothes on the 3D model as shown in this visualization by mapping triangles one at a time, starting from the marks. We now describe how to manipulate clothes on the body. A typical approach in cloth simulation systems is to move just one vertex explicitly and to rely on simulation to propagate the effect to the rest of the clothing. But this tends to cause a large local distortion, so it's not really useful for more global operations of the sort we perform when we put on clothes each morning. To solve the problem, we turn the user's simple input motion into displacements of many vertices at once, creating a global effect. Now the user can drag the clothes upwards, downwards, and even rotate them around the body. Here is another example. The user can drag the clothes on the body surface freely. 3D cloth geometry is maintained appropriately during the process. From this example, you can see that cloth is more than just a texture. Pushpins help the user control the behavior of clothes during surface dragging. Without pushpins, the clothes move freely. But a pushpin fixes a region of cloth, helping the user perform more detailed operations. Pushpins are useful for blocking the propagation of surface dragging across the entire surface. Now the user can undress the body, or can push the sleeve upwards without moving the rest of the shirt. The user can use the wrapping operation to adjust clothes on the body too. Pushpins are used to specify the region to be rewrapped. Rewrapping is especially useful for topological changes like this one. Here are some more examples. Putting a scarf on an octopus and adjusting it. And a children's favorite, skin the kitty.